Hi everyone, my name is TING-WEI. Today I will talk about hybrid tests on reinforced concrete beam with explicit analysis by using ANSYS and LS-Dyna. We will focus on ANSYS process. First, I have studied a paper and I want to use one of the specimens they used, and I want to simulate in ANSYS. At the left side, this is the setup of the experiment, and there are 4 supports on the beam, and there is the text loading machine at the center of the beam. They have load as 5% drift. At the right side, this is the beam configuration, and there are shear and flexural reinforcement in the beam. I will model in my ANSYS model. Next, I sketch the geometries in the ANSYS, and I use the beam element to model the longitudinal rebars and stirrups, and then I use the study element to model the concrete. In the end, I differ study elements and line elements from new parts. The next step, we need to choose the material model in engineering data. And I can find material from explicit material, the concrete I can use. Next step, I need to set up the interactions for element bodies. First, I need to delete all of the contact region and set all bodies as the type of frictionless. And then I need to insert the body interactions and for the type of reinforcement. For our explicit analysis, physics preference, we need to turn into explicit, and the element size need to bigger, and we set the size of the element is 0.5 inch. For the purpose of shortening the operation time, I set the end time as 0.005 seconds. The initial conditions and boundary conditions, I select the bottom face of each 4 supports into fixed support, and then I select the center body to apply velocity of 500 inch per second for the initial conditions. Finally, I set the total deformation and user-defined result. For the user-defined result, I need to type damage O to express the plastic strain. To compare with the result of plastic strain in ANSYS and LS-Dyna, we can find that the damage developed starts from the web in the middle of the beam. The behavior of the concrete is shear crack. As time passes by, the failure more generally turns into flexural crack at the bottom of the beam. After this verification, we know that the model is correct to use in reinforced concrete beam simulation. Thank you for listening.